Hi there! How's your first day of learning? I am Teacher Dorothy and welcome to the second day of learning in Telemath Aralan. Today's lesson is the continuation of the first most essential learning competency, which is to generate patterns. In this session, you are expected to learn how pattern is being generated.
But before I proceed, let's have first the definition of a sequence. When we say sequence, it refers to a group of objects or numbers which follows a definite pattern. Let's have the following examples of a sequence. Number 1, 1, 3, 5, 7, 9. Number 2, 1, 2, 3, 4, 5, 6. Number 3, 120, 60, 30, 15. Number 4, 9, 6, 3, 0, -3, and so on. Number 5, 1, 3, 9, 27, and so on. Each number in the sequence is known as term. The first number is the first term, and it is commonly denoted by a sub 1. The second number is the second term, and it is denoted by a sub 2, and so on. The number or order of terms in a certain sequence is commonly denoted by n. For instance, if you are talking about the first term, then n is 1. If you are talking about the fifth term, then n is 5. Suppose you want to determine the 80th term of a sequence, then n will be 80. Remember that n always tells the order of each term. Let's take the first example. In the sequence 1, 3, 5, 7, 9. The first term is 1. In symbol, it is written as a sub 1 equals 1. The second term is 3. In symbol, it is written as a sub 2 equals 3. The third term is 5. In symbol, it is written as a sub 3 equals 5, and so on. The given sequence is known as finite sequence. Why? Because it has the first term, which is 1, and the last term, which is 9. If the sequence has the first term, but no last term, then it is known as infinite sequence. Let's have the examples given to you. Sequences in items 1, 2, and 3 are examples of finite sequence. Why? Because when we say finite, it has the first term and last term. The last two examples illustrate infinite sequence. Why? Because when we say infinite sequence, it has the first term but no last term. In number 1, the sequence 1, 3, 5, 7, 9. The first term is 1 and the fifth term is 9, which is also the last term. In number 2, the first term is 1 and the sixth term is 6, which is also the last term. For the third example, the first term is 120 and the fourth term is 15, which is also the last term. In number 4, the given sequence is 9, 6, 3, 0, -3, and so on. It has the first term, which is 9, but no last term. As you can see, -3 is followed by an ellipsis. This implies that the terms of the sequence continues. The same with the fifth example. In the sequence 1, 3, 9, 27, and so on. 1 is the first term, but it has no last term. If an ellipsis follows after the last number in the sequence, then the sequence is said to be infinite. This time, generating patterns will be discussed. Pattern or rule for a number sequence is known as the explicit formula that satisfies the succeeding terms of a sequence. At this point, terms of a sequence will be given and you are going to generate a pattern that will satisfy the given sequence.
Let's have the first example. In the sequence 1, 3, 5, 7, 9, and so on. The first term is 1, the second term is 3, the third term is 5, the fourth term is 7, and the fifth term is 9. Suppose you want to determine the nth term or the other terms in the sequence. What would be the pattern or the explicit formula that you are going to use? Now, let's generate the pattern. The easiest way in generating patterns is by using table. The table consists of two rows. The first row is for the order of terms, or A sub n. And the second row is the corresponding value. For the order of terms, we have the first term, where n is 1. Second term, where n is 2. Third term, where n is 3. Fourth term, where n is 4. Fifth term, where n is 5. And for the last term, or nth term, where n is unknown. And for the corresponding values, the first term is 1, the second term is 3, the third term is 5, the fourth term is 7, the fifth term is 9, and the nth term is unknown. You need to know first how each term is obtained. First, you have to describe the pattern. Notice that each number is obtained by adding 2. Adding 2, adding 2, adding 2, adding 2 each time. And if you think about it, what is the faster way of adding 2 repeatedly? If you want to come up to the nth term, you have to add 2 repeatedly. So what is the faster way of adding a bunch of 2's? Multiply by 2. So the formula begins with n times 2, where n refers to the order of term. It's times 2 because we keep repeatedly adding 2's. So the faster way of adding is to multiply. So here is the formula. N times 2. Let's start with the first term. If we look over here, n is 1. Let's substitute 1 to n. 1 times 2 will become 2. We don't need 2, but we need 1 as the first term. What will you do? Let's try for the second term, where n is equal to 2. N times 2. 2 times 2 is equal to 4. But you need 3 as the second term. So what will you do? For the third term, n is 3. N times 2, where n is 3, times 2, the answer is 6. But we need 5, not 6. What will you do? If we use the generated formula, we get 2 instead of 1. We get 4 instead of 3. We get 6 instead of 5. This means that the formula needs a little adjustment. What will you do to 2 to make it 1? Simply, you subtract it by 1. What will you do to 4 to make it 3? Simply, you subtract it by 1. And what will you do to 6 to make it 5? Simply, you subtract it by 1. With this, you will subtract 1 from the formula. And it will become n times 2
minus 1. Let's test it out on the fourth term, where n equals 4. Using this formula, n times 2 minus 1. n is 4 times 2 minus 1. 4 times 2 equals 8. Then minus 1. 8 minus 1 equals 7. This is exactly the answer that we are hoping for. So this generated formula indeed is the correct pattern or rule that will satisfy the given sequence. Again, the generated pattern that satisfies the given sequence 1, 3, 5, 7, 9, and so on is n times 2 minus 1. Always remember that any formula or expression should be written in standard form. Therefore, instead of writing the formula as n times 2 minus 1, you can write it as 2n minus 1. This is now the generated pattern or the explicit formula that we are looking for. Do you have any questions? It seems that you learned a lot from our lesson. So, this time, I will give you an exercises for you to assess yourselves whether you really learned from our lesson. I have here 5 sequences. All you have to do is to generate the pattern or rule or what we call as the explicit formula that will satisfy each sequence. You only have 20 seconds to answer. Number 1. The given sequence is 5, 8, 11, 14, 17, and so on. Your time starts now. Alright, what is your answer? Correct, the answer is 3n plus 2. Try number 2. The given sequence is 2, 6, 10, 14, and so on. Your time starts now. Alright, what is your answer? Correct, the answer is 4n minus 2. How about this sequence? 1, 5, 9, 13, 17, and so on. Your time starts now. Alright, what is your answer? Correct, the answer is 4n plus 3. Let's have number 4. The given sequence is 13, 11, 9, 7, 5, and so on. Go! Time's up. What is your answer? Very good. The answer is negative 2n plus 15. Let's have the last number. The given sequence is 10, 9, 8, 7, and so on. Your time starts now. Time's up. What is your answer? Exactly. The answer is negative n plus 11.
That's it. I hope what you have learned today made your day productive. Again, I am Teacher Dorothy and this is Telemat Aralan.